TV from other dimensions has a somewhat looser feel to it.
Yeah, it's got an almost improvisational tone.
Hey everybody, it is 20 Point Tuesdays. We're loading up. The first question was, can we go over some 320 and then some 474 next? Let's go over here and I'm going to grab 320 and 474. So we've got the 474 open. How is everyone doing today? It is Tuesday. I tell you, what are we on, week 5 or 6 of the semester? Oh my gosh, it's just flying by. Like it's just like instantaneous. So I feel it. Hopefully everyone's feeling all right. Semester is just quickly going by. I can't believe it. September will be over soon. And then October, we're already like, and this is a full month of school right here. We started in August. Gosh, it seems like we just started yesterday. And then we're already like so far into the semester. So we've got everything pulled up right here. Let me switch over to the Snap to a 1 transition right here. First day of fall. It is the first day of fall. So excellent stuff. Love it. First day of fall. Let's get right here. And let's go ahead down to question. Oh, we need to open up the slides right here. So let's go and load up the examples. So we need to load up the data. Class is not over. I'm just getting things loaded right now. Open slides, homework solution, our homework. These are solutions. We don't want the solutions. I want the homework packet. There we go. Here we go with the homework packet. We got the homework packet open. So questions were on 320. Can we go over for 320? Let's go down here and look at 320. So questions 3B, was it 3B and D? Are you looking at these right here, Mohammed? So these questions right here, questions 3B and 3D and 3C. So with these right here, these are the questions right now, and let's review. So the important part of 3B, let's talk over 3B right here. So with 3B, what are we learning? What are we covering with 3B? So 3B is asking about, let's go look at it again. 3B is asking about the F statistic. So interpretation of F statistic. So when you think about an interpretation of an F statistic, what we want to focus on is we want to focus on what an F statistic is. And the F statistic is going to look something like the following. It is the observed differences between the groups over what we would expect the differences to be. So kind of the observed variation between the groups over what we expect the variation between the groups to be. So when we look at this right here, if we have graphic 1 and graphic 2, which of these graphics show no differences between the groups? You know what? I can do the trick. We've got a trick to showing no differences. Well, that gives away the answer, doesn't it? So which of these shows no differences between the groups? Which of these graphics, graphics A or graphics B, show no differences between the groups? So which of these shows no differences between the groups? And this is how we can understand what the F statistic is showing us and kind of get at what is the F statistic. So you have to look at the differences between the groups and which of these show no differences between the groups. Which of these show no differences? And then, so once we figured that out, we have to think, well, what would the F be for these? Because the F, I'll go over here and do some writing while people are thinking this over. The F is going to be the observed variation over the expected variation due to random chance. So which of these, A or B, show no variation between the groups? Which of these, A or B, shows no variation between the groups? Any ideas? Which of those, A or B? 100 points out there on this question. A or B? We'll see if Mubot knows while people are thinking this over. Which of those shows no variation between the groups? Which of those shows no variation? Mubux is go getting some pumpkin spice latte and not here to answer questions. Which of those shows no variation? Maham, do you know which shows no variation? Graphic A or B, which shows no variation between the groups? So the big thing is that this right here is the observed variation between the groups. Does anyone know? That right there is the observed. So that's what we're getting at right here. So which of those shows no variation between the groups? Jake and Park, this review right here of 320. And this is also good for 201. It's good to talk about the differences between the medians or the means. And we're looking at medians right here since these are box plots. So those are medians. Oh, I can just barely touch them. So the observed differences between the groups. Graphic A or B, which of these shows no difference between the groups? Which of these shows no difference between the groups? Make sure chat is still running right here. Let me go over here. Which of those shows no difference? Awesome, Monks. Good to have you here. We'll be doing more in a second. Looks like chat is running. So which of these shows no differences between the groups? You think you got the while loop correct? That's awesome. We'll definitely be doing some 474. We might jump over to 474 of 320. I don't know. Mohammed, are you still here? Do we lose people? No. The one with no difference. Do you know which one? B. I'm giving you 1,000 points of the week. Thank you for helping out here. B shows no difference between the groups. And think about this. What we'd have, it's been well, but it's B, you're right. And so what we have right here is the observed over the expected. We observe no differences between the group right here with graphic B, and then A has a difference between the groups. So these are just estimates, but maybe the F for this graphic is something like 5, and the F for this graphic would be something close to 0. And think about this. We're saying how much of the observed variation we see versus the expected. So this is telling you you saw none of the variation between the groups that you would have expected to see. There's no variation between the groups that you saw, and it's 0% of what you expected. You could get, sometimes you get an F of 1. We'll do an example C down here where you get an F of 1 where maybe it looks like this. And I want you to think about what this means if we see an F of 1 right here. If you see an F of 1, and look, these do not perfectly match up. I'm purposely making them a little off. But if you get an F of 1, what would the F of 1 here mean? If the F is equal to 1, then the observed and the expected were what? The F of 1 would state that this observed difference between the group means, or medians, depending on if we're doing means or medians. The box plots are medians, but we can also use an F for means. So the variation, or we traditionally use the F for means, I should say. So the F of 1 right here would mean that the observed variation between the groups was exactly what you expect due to random chance. So do you think in any way with an F of 1 this should be statistically significant? If we're saying this is exactly what we expect pretty much due to randomness. Like if this is a random relationship right here, this is what we expect. It's what is likely. It's what we think would happen if it's random. So that would be a very, very, very what p-value? The p-value, since this is likely, we would expect it. It's very common. The p-value would be very high because this is a likely difference. And up here in graphic A, this is a very unlikely difference. So this graphic in graphic A has a very large difference that is unlikely by random chance. And so all of these graphics right here would actually need their associated permutation distribution. And this is where we get into the remaining questions on this. The associated permutation distributions is where we plot our result. So the important thing here is to plot our result. So when we plot our result, we go down here and we plot our results and we put a red line where our result is at. So this one would be at 0 right here. And this one would be at 5 if 5 is over here. And then we shade the area to the right of it. And now what do you notice about graphic B? What percent of the curve on graphic B am I shading? What percent of the curve on graphic B am I shading? I'm shading 100% of the curve. So this right here is a p-value of 1, telling us that this or something more extreme would happen all the time due to random chance. And then the one on the far side has a very low p-value. So it's very important to note that this is the p-value right here. And you can do this for your graphic. You can submit this for the assignment because on the question it has for ours, for the question on the assignment, it literally shows the graphic right here and it says the F is 4.7. So if we want to talk about what the p-value would be, we need to go here, grab this graphic, and then drop it into a Word document. And we go right here and we put our red line. And the p-value looks to be about what? I can't even see it. If there's anything there, I don't see it. So the p-value, is that going to be statistically significant or not statistically significant? What percent of that curve does it look like I've shaded? A very small or very large portion. And this will relate to the p-value here being very large or very small, because that's the probability of our results or results more extreme happening by random chance variation, given that there's no association, which is the null. And so with this right here, the p-value looks to be very, very, very what for this question? The p-value looks to be extremely small. So we would have a very, 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 very statistically significant p-value. Management only cares. So for this one, we have to go back here and you have to wonder, is the difference between these groups more than 1,000? So one of the best things to do is go over here to the side of it, and then to figure out if the differences are more than 1,000. So if the management wants to know, is this difference more than 1,000? What are we talking about? Statistical or practical significance? This is a big thing to know for 320. If they're asking, is the difference more than 1,000, would that be statistical significance or practical significance? Now, someone might argue you have to look at this one first. You always have to look at this first, and then you can look at this. So you have to think, what do we always look at first? Statistical significance, which would be the p-value we've just obtained. And then we can start wondering about practical significance to see if it meets a certain standard that's kind of arbitrary. And so I think that does it for 320. If you have 320 questions, ask more. 201, if you're here, ask questions. We got some 474 right now. The questions for 474 are, I'm already on this side of the screen. We've got here 2A, 2B, 2C, and 5. Let's take a look at question 2. Let's do that right here. What does everyone have for lunch today? Let's talk about lunch. Let's talk about, what did people have for lunch? I had yogurt. Exciting times. Use an if-else. So pizza, oh man, what kind of pizza? That sounds amazing. So convert is rich to a factor and then provide a summary. So if-else is a really cool function right here. So understanding the format of if-else, which is what I'll kind of go through here. I'll talk about the format of if-else. So after statistical significance, I can say by looking at the graph. But remember, so Ting Yang, before we go over to 474, you want to look at this right here and say, does it have more, like you want to estimate these differences between the medians. Do you see these medians right here? Is that more than 1,000? So visually speaking, does it look like there's a difference of more than 1,000? So we need to look at this and say, from Friday to Monday, from Monday to Saturday, or just any of the days, do any of the days differ in their medians by more than 1,000? And the reason I've highlighted this right here is this is a length of 2,000, so this is about a length of 1,000. So I want to see this variation between the medians. Some are smaller than, I think all of them are, not to give away the answer, but I don't think any of these are bigger than bigger than 1,000. And truthfully, I can tell you the answer here. I'll show you real quick. This data frame is the EX7 bike data frame, one of the EX bikes. Data EX3 bike, 4 bike. Here we go. And let's go here to aggregate, cool function aggregate. And do we have weekday? No, it's going to be the other one. There's an EX4 bike and like an EX7 bike. There it is, EX7. Wow. Kind of scary when I know these things. And so there's this one, and there's day, and we want demand. So we want to look at demand, day, and we want to do fun equals median. Did I do it correctly? Nope. Demand not found. What is it? Demand? Oh, haha, data equals. Y tilde x comma data equals. And EX7. There we go. And here's the demands right here. So visually speaking, none of them are different by more than 1,000. Saturday is 4903, and we can trace that over right here. So Saturday is at 4903, and that's where it traces to right there. And then the lowest day is Monday at 4559. And so Monday is actually the lowest, and it's kind of nice that they're right next to each other. So if you look at it, there's the difference between the two, and it's definitely less than 1,000. Does that make sense there, Ting Yang? Right there, we've got about a difference of 300-400, I think it was. We could take and subtract these differences inside of R right here. So, yep. And so these differences right here, you can just take and subtract and see the difference. The difference we are observing 350 or something, 344. So we are observing a difference of 344, which is way less than 1,000. So it's about a third of what management is interested in. So this would not be practically significant. And so that's how you can get the medians right there for all the things. Aggregate's such a nice little function. You can just find out whatever you want, the standard deviation, the means. So I wonder if, I think I've tried this before. I don't think it works. I don't think you can concatenate. Yeah, it doesn't let you do that. It'd be a lot more work. Ugh. If you want multiple things, it'd be a lot more work than I'd want to do. Yeah. I know how to do, I'll do it really, really quick here. No, we need to do something else. I know how to do it. I'd have to column bind onto a data frame. So that's going to be less fun than I want to do. So you should use dplyr actually. So for those who know dplyr with mutate, I think is the function. So let's go ahead and look at question 2. Use ifelse to create a categorical variable called isRich that takes the values yes when the money column of junk is greater than 1 and no otherwise. So we're going to look at the money column in this data frame junk. And the data frame junk is inside of reg class. You can observe this here. So this is the junk data frame. It is now loaded in. And we're just going to clear the global environment again so we can just see this one data frame. So when you look at this data frame, here's a big thing. Anytime you bring up a data frame, usually open it up just to take a look. This is a huge data frame with emails that were sent. And we want to see like the proportion of times that something was said in an email. And so we're looking at all the different values right here to see multiple things said throughout the email. There's like exclamation points. There's labs, telenet, George. I don't know why George is in an email. So all these different things right here. And then we're figuring out if it's junk or safe, I believe. Those are the two variables. Just right here, junk, and it's junk or safe. That's what we're trying to predict for this data frame. So with this data frame right here, let's go ahead and think about what we could do. We have a vector right here of junk. And we have something like, let's see right here, report. All these things I get now saying they'll report me. So if they were to say report me, it'd be greater than 0. Now I've turned this into a logical vector. And we could simply take this, and this is not your question. Let's put a note right here. Working a slightly different question. So we're working a slightly different question. And we have here whether or not someone will report us. And this is the big thing. The if-else takes a test across a logical vector. And then if we have a true, here's what it will do for the true. I'm going to have it say yes. And then if we have a false, then in this argument, it'll return this. So you can observe this, that these are going to be turned to yeses and nos right here. And then if you want them to be a factor, you simply wrap it inside of a factor right here. And then you have a factor vector right there, and you can store it into something. So I could call this reported. And so this is my reported vector right here, and I can see the amount of ones that have reported in it, and 357 have reported in it. Does this make sense to everybody right here? How to use the if-else function? This kind of covers this question. Didn't do it exactly, but it's pretty much the exact same logic on using the if-else to recode something and then storing it as a factor, which I think it wants, to a factor and provide a summary. So to provide a summary, we can do the same thing, and it'll do the same thing. Can you over 2, B, and C as well? Yeah, I did them, but my answers don't match up. Cool, let's do it right here. Use if-else to create a categorical variable called sales-related that takes on the values of yes when any of these right here. I was helping someone on Discord with this, and I always try to give small hints. You got it, Monks. That's awesome. Great job. Yeah, once you get it, you're like, I got it. You know what? I'm going to do this one because someone's saying their output's not lining up. I'm just going to straight up do this one. This will help out. So 2B, we're doing this question here right now. So this is your output. Okay, let's take a look at this. Okay, so what we have right here is multiple conditions. So we have here, we're looking at make, order, and money. So there's a lot of ways to do this. You could break it apart. I need a vote, or just for someone tell me. Should I do this in, like, it's not how I usually code. Yeah, I think, Jake, we might have been talking on it. It's using all 3 conditions with ands. So you just have to write all 3 conditions with ands, and I'll show you the 2 ways I was thinking. Since I'm going to do this one, I'm going to do it 2 ways. And then, you know, like we say, if you can do it multiple ways, you've got it down. So we're going to go to junk, we're going to go to make, and then we're going to go to junk, and then we're going to go to order, and then we're going to go to junk, and then we're going to go to money. And so these are all vectors. We're going to see if they're greater than 0. Greater than 0. You know what you could do? There's a quicker way, I think. I think somebody because you can do vector addition. So why don't we do sum of, oh, let me do the first way. Here's first way. We'll do it 3 ways. So we're going to do a condition right here where we say, is this and this and this greater than 0? So these are ones that meet all 3 conditions. So when we look at a row here where there's a true, which hopefully we see a true early on, if you look at where a true is, like in row 1, 2, 3, 4, 5, 6, then row 6, if we go to these values, so if we go here and look at row 6, it should have a value greater than 0. If you go to row 6, it should have a value greater than 0. If you go to row 6 for money, it should have a value greater than 0. Does everyone see how I'm checking that it meets all 3 conditions? Because I think we're saying takes the value when have a value greater than 0 and no if none of them do. Okay, wait. So use this to create a category variable called sales related, takes on the value of yes when any one of, oh, we got an error. We got an error. Hopefully I didn't confuse anybody. So now this wants this or this or this, and now we want any one of them. It's only no if it doesn't have. So if this is greater than 0 or this is greater than 0 or this is greater than 0, we are good. Hopefully, I'm sorry if I confused anybody. And now this is our condition, which you know what? We could just call this, let's call this vector condition. And let's run that. And let's put it inside of here. And let's go, you shouldn't use ands. We should get the same output. And it's going to be yes, no, factor, and then what does it want us to call it? So sales related. And then sales related right here should be a, we can do a summary. There we go. That's got it right there. So we're able to do it. It should be the ors because we want this or this or this. Yeah, I think so. And I think I told, you might have been the person, Jake, I was telling to use the ands. I'm very sorry about that. I think my mind was just like, yeah, we want to see if this and this and this and this. And I didn't realize it's saying at least one, which would be this or this or this. So it's all good. Thank you so much. We all make mistakes. If you turn something in with a mistake I told you to make, just tell me and I'll fix it. So the theory behind this question is at least one of them is greater than 1. So if at least one of them is greater than 1, we should be able to do it the other way. Because we could do, watch this. I did get it. I did not, the part I didn't. Oh yeah, greater than 0, yep. So you have it, I guess you have it now, Peyton? Does that make sense? I'm gonna do it another way right here. Let's do the sum. We don't even need to do this. Let's call this amount. And so we could add these vectors. And so by adding these vectors right here, we get the amount. And let's see where amount is greater than 0. And you know what? Because this has got it right here. This is a different way of doing it right here. So there's so many ways to do this. And let's check our output. I don't know if I can think of a third way. Yep, same output. So both of these ways, there's the first output, there's the second output. So theoretically, the second way I did it, let me increase font size here. The theoretical way I did it, the second way, is I added together all 3 of them. And if one of them is greater than 0, then we will get a value greater than 0. So by just adding them together, data frame and some, yeah, you could set up as data frame, yeah. And so that's like the complicated way. Let's do that way. So if you wanted to go here and go data.frame, and so we're going to store that as data frame. You can use it, but I like to store it first. And then we go here, vector 1, vector 2, and vector 3. So there is the data frame right there. We're going to call this, and this is not a logical check, so we wouldn't, since it's not a logical check, we won't use the equals equals. Someone asked me, said, why is it not equals equals? And it's not a logical check. So it's telling me that wasn't that way. So now we have a data frame. Let's take a look at it. So you can see the data frame right here. And we should be able to do the sum of each row in the data frame. So you could do it with a for loop. Here's the for loop. And we go right here. And we need to start, well, we're not going to do it this way. We're going to do it the right way. We're going to code this by coding with a for loop and doing the first row. So you want to go to the first row in the data frame, which is going to be row 1 right here. And there it is. And then we want to go to the sum of row 1. And there's the sum of row 1. And then if sum of row 1, so if sum of row 1 is greater than 0, then do yes, else no. So that's got that. That's my loop. Let's just run it. Works. And then 4, drop it in here. I, and then I right here. 1 through n row. And once we do the number of rows in our data frame, we need to store it. Haha. So let's call this answer. And then answer needs to go into a vector. And let's go this full answer. Full answer position I. And then we go here. And full answer store into factor full answer. And then summary full answer. We'll look at this in a second. This is just the third way. This is the overly complicated way of doing it. Okay, I think I have everything. I think I've done it. Could not find full answer. Forget one thing. We need to create the vector full answer because it can't store into it yet. And there we go. Talk about a lot of work to get to the same answer. So if you notice the if else, I kind of did this for a reason. The if else does the for loop for you. It's a lot more work the way I did it right here to get to the same answer, but kind of practicing these things and being like, can I solve this a second or third way is a great way to see. And since I did do this problem, I've now put 3 ways to solve it on here. And it's really just good practice to see if you can, I don't know, it's like a logic puzzle. You've got basically 2 ways that are identical in nature, but different how they make the condition. And you've got a third way that incorporates a data frame, a for loop, an if, if else. So really good practice on what this is doing. Who thinks they can understand the structure of this right here? Like I'm making a blank vector. I'm making a data frame which has named vectors at the top of it. That just gave names to the vectors right there. So they make order money. If I didn't do this, it wouldn't have a name at the top. It would just use that name and it wouldn't look as nice. And then, so I was just really making things look nice. And then here I went through and did a test on each one of them to see if it was greater than 0 for the sum of the rows. So that's got it. And that's got the answer right there. So 3 ways, same answer. And 3C, use a for loop and if statements to create a categorical variable called exclaim. So this one right here, I learned to read the problem. Yeah, I know, right? I do it all the time. Like reading a problem incorrectly that is what I'm good at. I'm good at reading problems the wrong way. I seriously like change the words when I read it. Let me decrease font size. There's the answer. I'm not going to use the helper things. No. Okay. So when you do this right here, I like to do a separate example, working a different problem. So think about this. We were talking about 320. Imagine we're looking at the bike demands. And let's go bring us back to 320 right here. Let's recode bike demand to be high, medium, or low. So where should high bike demand be? Where should high bike demand be? What days would have be very... I wouldn't go super high. If you're thinking something, yeah, that'd be really, really high. But what might be high bike demand? Actually, I see some really good marks on here for high and low and medium. Kind of because of like, if you're dividing things up, where do you think high, low, and medium would be? I see some really good dividers. And I'll explain why. Who's got it for, I'll give you the full 1,000 points a week. Where do you think high, medium, where do you think we should have the dividers between high, medium, and low? We only need 2 dividers because it's like, if we're cutting the class into 2 groups, we would just cut down one spot. It'd be like, okay, after student 8, you're cut there and then you're split into 2 groups. So if you do 2 cuts, you get 3 groups. It's like a big pizza. If you do 1 cut, you get 2 slices. If you do another cut, you get 3 slices. So where do you think we should cut to make our 3 groups? 1,000 points of the week. Who's got it right here? Who's got it? Who's got the answer? Well, these are in thousands. Good guess there, Parker. This is at 2,000, 4,000, 6,000, 8,000. Where do you think? And look at the box plots to think about where the data's at. Here's a hint. We have right here that this is the minimum. So these are all the minimums. These are the 25ths. Yeah, exactly. Yeah. I would say, Peyton, I'm with you right there. I think this is a good mark for high because this is the upper 25% of most box plots. And then 4,000 to 6,000 seems good for medium because that's 50% of the data. And then the low would encompass the remaining like 25% if we go below 4,000. So I think low, and then this is more things will be medium, and then 25% will be about high by most of these box plots. So I'd say 4,000 to 6,000 are a good cutoff for like below 4,000 is medium, 4,000 to 6,000 is below 4,000 is low, 4,000 to 6,000 is medium, and then above 6,000 is high. So that's probably where I'd put my cutoffs right there. So we're basically doing 2C right here. And what we want to do is we want to go and go EX7. We're going to call the data frame. We're doing a slightly different question. Oh, data, EX7, bike. And then we want to go right here and go EX7, bike, demand. And we want to look, is the demand greater than or equal to 6,000? And these are the ones that meet the condition. So there's a few ways to write this, and it says to do it with using a for loop and if statements. So that means we're going to do it for one of these to check. So let's go here and check the first one to see if the first one is greater than 6,000. So we're going to see right here, if this is greater than 6,000, then we will run the code high and nothing happens. Because why does nothing happen right here? Because this evaluated to what? Nothing happened because this evaluated to what? So think about this. The demand for the first day was this. So that means that when this ran, this evaluated to false. And since there's a false right here, if this is false, it doesn't run the code on the right side. If it was true, it would run that code. So that ran as a false right there, and it just didn't do anything. So what we can do is it says just use ifs. We basically have our structure right here, and we can take it and we can say if it's greater than or equal to 4,000, and this is where you have to be careful. Let's grab this right here. And we want another condition. We want it to be less than 6,000. Then we want to say medium. And we already saw that it's 900 something, 985. So this shouldn't run either. Doesn't run. Now we just need the last condition right here. If it's less than 4,000, don't know why I deleted those zeros, I still need them. Low. And that runs. So now we have it working on the first condition. Who knows, 324.74 for your 1,000 points of the week, what I built. And Parker, you got your 1,000 points of the week for answering the question. And Peyton too. Who knows what I just built right here, getting it to work on the first one. Who knows what I built right here, getting it to work on the first example. So I have it that it'll work on one of these. I could just go here. Ah, wait, you're close. I could go here and do the following. So I can do this right here now. I can run this. And then I could change it to the second one. That one's also low. Are these in order? I think they might be in order. Let me look at bike demand. Because it's kind of weird to see them like that. Oh. Oh, it's just a few low bike demand days. Wow. Wow. Jake, you're right. We built the skeleton right here. Here's our skeleton, and that's me seeing if it works. And so we go here, we go I, and we go 1 through the number of rows in EX7. We put in the skeleton, and we do need to capture this. Oh, I didn't do that. So let's go right here, and let's go to, just thinking where to put it. I should have, let me do this before. I didn't write the part that captures the answer. So we need to go here, and I like just calling things answer. It's my usual thing to call something. And we want to go here to answer position I. And we want to store into there. So we're going to store into answer position I. So just so you can see what's happening right here. Yes, it's still on the screen. We got it. So we're storing into answer position I. And will this work? Looks like it ran. And let's go here to answer. Capital answer. And it's stored into the third position. Hey, what's up, Calzone? So good to see Calzone. You should show him your points. Calzone. People were asking about tiers today in class. They were like, what's the top tier? And I said, no one knows. Maybe Calzone Talrone knows. So good to see you here. Oh my gosh, you're about to Look at that right there. 100, like over 9 million or 9 billion, like legendary tier right there. I'm not even at that tier. I've been trying to get to that tier, but we try. I know. Cue the sound. Yeah, I'm only at gold tier. There might be even more tiers that we haven't seen yet, so stay tuned as people get to higher and higher tiers. I know, like Jake, if you want to, like, I love showing points and everything like that. It's so much fun. Got bronze tier right there. So we got all different tiers, and I think this for loop's ready to go. So we got silver tier right there. It's awesome. So good to see you. How's your semester going, Calzone? Not to get too personal. You don't have to say anything if you don't want, but going good. Silver now, love it. And I think we've done it. I think we got the answer here for this code. I might decrease font size. That's good right there. Okay, so what should I do next to this? Yeah, let me try posting this. Is it going to go over the character limit? Oh, no, it did. You're going to have to grab it in 2 parts right here. Okay, wait. Let me try to do this. Okay, so... Okay, here's everything up to the medium. Yeah, it's a lot of everything's totally online. Are any of your classes on YouTube? any YouTube classes? Anyone being like, let's do this? Maybe be like, yeah, they're all on YouTube, and I'll be like, oh man, I don't feel special anymore. I don't feel special. I'm gonna turn this into a factor right here, and that just turns all those into a categorical variable. I'm gonna take the answer right here, drop this right here, do this. I'll drop this in the chat too, and now we can show a summary of answers. There was one time you came to a class, Calzone, someone was like a little bit mean to you, and I felt so bad. Someone was like whatever to you or something. I was like, don't be mean to Calzone. This is fan favorite here. So, I'm enlarging the chat now. So, what do we have, and what questions are there? We've done a lot today so far. We've talked about a few questions right here. What other questions are there? What other questions are there? 4B would be awesome. Let's go talk about 4B. I'm going to do kind of examples like 4B. 4B. Did I find 4B? Did I do it? I did. Okay, let's do this. Calzone, we got so much more music now. This is the Thanos thing right here. Previously. I could play this in like the corner.
Previously.
Put this,
on Stat 201.
Well, we can't show this yet. It's locked.
Hey Brian, what's up? Hey,
Adam, just show this over here.
Adam, what are you doing?
Should just put it over here.
No!
Like, play the thing in the corner. We'll just watch that up there in the corner. So where did I put it at? Thanos. Brian is gone. Brian's still here. Is there chapter 6 homework help in your office hours? Yep, GG there is, and we could do some chapter 6 after this. And then Parker wants Q3 and Q5. Is it on this one here? So we'll do some 4B, and then we did all of chapter 6 GG, and it's in videos, so I can do more of that. GG, do you want us to do a specific one from chapter 6? We can do that next because we haven't done any 201. So GG, feel free to ask, say, hey, can you do this problem? And we'll work that problem and explain it fully right here for you, because I try to jump around between the classes, and we haven't done any 201 today yet. So if you want, say, can you do this problem? The homework's on the conditions. You got it, Parker. We can do that here next here. So let's look, and we'll see if GG has a question here. Write a for loop that breaks. Okay, so, yeah. And so, do I have the plagiarism checker up? 2 seconds, class is not over. Okay, so there's some things you can put into for loops right here. So you can put these things into for loops called break or next. We didn't cover next in the assignment, but what do you think a break does to a for loop? What do you think a break does to a for loop? If a condition is met, or if you put a break in there, then it'll stop the for loop. The for loop will end. What do you think next does? When my for loop runs here and it tries to read a document, if there is an error, what do you think my for loop does if there's an error? My for loop tries to run if there is an error, which this code basically says, if there's an error reading the document, because it tries reading the document, it stores the result into test, and if the test result had an error, then what does it do? It goes to the next. Because I don't want it to actually, I want it to try reading the test. I don't want it to actually do that. That's what the try code does, as best I can understand, because I even had to look up some things to figure out how to code this. But in my plagiarism checker, I'm loading all the documents right here, and then if the document doesn't load, I skip it. So does that make sense why I say, like, if the document did not load, that's what this code might as well read. If the document failed to load, there was an error, then go to the next for loop. It's just going to end the for loop here and go to the next one. But if I put break right here, what would happen to my whole for loop? It wouldn't just go to the next loop. It would just end the for loop. The for loop would stop. The for loop would be over. No more for loop. For loop done. So I don't want it to end. I want it to go to the next version of the for loop. So, oh, it even has its own little thing right there. So really fun, really cool thing right there. And I had to see what to use to do that. I was like, I want it to go to the next version. So with this right here, we have to put in a condition. And the condition is just checking to see if it meets certain values. So we want to check to see if it meets a certain value. So how will we do this? Here, I'll write the conditional part of it. So we want to find the position of the first negative odd number. So we want to look at this right here, this vector, want to run it. And we want to go to this vector and we want a negative odd number. So if it is less than 0 and the modulo of x when divided by 2 is equal to 1. So here we see the first position is this right here, and this is the condition that will break the loop. So let me put a note on this. Condition to break loop. So I think a lot of people are getting confused on the next one though, because if you're running a while loop, condition that runs while true, you'd actually want to see that x is either this or this. This is help with the next one here. And we want is not equal to this. So think about this and just look at the way this is written. When we ran the first bit of code right here, this is telling it where to break. And the if will tell it to break where the true is. Does that make sense for everyone watching right here? If you're saying, if this evaluates to true, break my loop. So it'll break the loop right here. So this is a condition to break the loop because it's saying, if this is true, break the loop. And this is where it breaks the loop. But then if you have a condition for a while loop, if this is true, continue to run. So it'll stop running here. So the while loop continues to run while the condition is true. And the if function only runs code if the condition is true. So you can see here in this first line of code why this is the condition to tell the code to break, because it'll break when the true hits. It'll say, if this is true, break the loop. And then this one right here is for a while loop saying, if this is true, continue to run the loop. I think that's where some confusion is on this problem. I haven't worked the problems out fully, but I think just writing the condition right here should help with understanding that this one here is saying, if the numbers are less than this or odd, if they're less than 0, if they're negative or odd, then break my loop. If the number is either one or the other, if it's positive or is not odd, then continue the loop. So it'll only stop the loop on the false right here. That's when the loop will stop running, the while loop. Does this make sense to everybody? And we'll see. So I think we still have a 474 question. Parker wants to know Q3 and Q5. Which one are you most interested in, Parker? Q3 or Q5? Take your pick. Q3 or Q5? We can talk about some generalities. Parker, take your pick on Q3 or Q5. Just going up here to Q3. We gave some helpful hints in class today on this one, so I might go do a Q5 right now because we ended class today on this one, and I gave... Oh, so nope, Parker picks Q3. Parker, you're here, so we're picking Q3. So when you look at this code right here, what you want to understand is that this code right here always has a variable here and a variable here. You get to pick these. And this is the vector. And so we have two vectors. And probably the most important thing to code, which basically gives away the answer, is the skeleton of the for loop. The skeleton of the for loop is asking us to find the absolute value between, we'll probably do it next year. No one's asking other questions. So Parker, you've got the floor. And so we'll go here to the absolute value of the matrix. And what do I want to do? I want to take the values that are, we don't want to do absolute value yet. No, we can. We want to take the absolute value of what was ever in position 1 or the numbers, right? Oh, it's much easier than that. So we want to take the absolute value of 1, 1. And we want to do 1 minus 1. And we want to store this into position 1, 1, if I could type. So when you run this, I think we've got M made. There's no M. That was what I feared. So when we run this right here, it stores. And then what we want to do is we want to switch from the first row to the second row, and then we want to put this in here. Now this has to go all the way through. We have to continue all the way through this till it gets to 100. And now what happens here when we get to 100? What's going to happen to the column? The column will go to what? If we're looping through a for loop and we're going through all the rows, and visually it would look like this right here. We're going to go through all the rows. So after we go through all the rows, we'll switch over what? We're going to go from 1 to 100 on all the rows. Then we'd switch over to what? After we go through all the rows, we'll switch to a different what? What will we switch to then after we go through all the rows? After we go through all the rows. So we went through every single row. You got it, Parker. Great work, Parker. 1,000 points of the week right there. So we'll switch to a different column. We'll go through that. Then we'll switch to here. Then we'll go through this. And sorry, my lines are not going all the way down. They should. But we'll just keep switching through all these right here. And we'll go all the way here to the 100th column and the 100th row. And that's what we'll have done. We'll have gone all the way through all the iterations of everything. And so you have to think about how we're going to do this. How are we going to go through these numbers? And the for loop is the process. Because when we do this, we need to put in placeholders like row and column and row and column. And this is the code that'll run. So we're so close. We've talked about all the theory right here. And this is not the answer, but this is all the theory behind it. So now we're just moments away from putting in our right variables and our right vectors, and then we'll have the answer. So is this making sense here, Parker, that we need to talk about, you remember, I've already got variables in place right there, and then they just need to go through the variables, they just need to go through the vectors, and we will have the answer. Does this help out? Does this make sense? This is about as far as I've worked the problem, generally speaking. But at this point that we have the skeleton written, yep, Parker, that's what I want to see. I like to get people right to where they're like, okay, that I have to change the variables now, I have to change the vectors, and it's going to go through. And visually, kind of understanding visually what we're doing, that we're going through all the rows, switching the next column, going through all the rows, switching the next column, going all through rows. You've got like here your inner loop and then your outer loop. As I kind of make a mess of this, inner loop, outer loop, inner loop, outer loop, inner loop, outer loop, inner loop, outer loop, kind of like that right there. So awesome work right there, Parker. So good to have you here. And let's go down to number 5. So with number 5, I get people to a point, and I think people are getting stuck on this. You know what, I might, with the 2 parts of this video, you know, the harder part's the while loop. The while loop is the harder part of this loop. And then just understanding what you have to do next is the easier. The while loop is the harder part. And then putting inside the for loop is the quicker part. But you still have to know what you're doing with it. So with this while loop right here, we need to code an instance of it first. We're trying to see if we have a 0. So we want to go to this matrix X, and we want to go to the first column. So the first column, Q5, I still have it repeat 333 instead. I think you're not switching your columns. Here, I'll tell you the most common mistake I see. This is the most common mistake I'm seeing when people send me their work. Where's my while loop? Really? There we go. The most common mistake I'm seeing is that people have the variable out here as I. You should not have this variable as I, because this needs to change the column. So you could call it C. Kind of makes sense to call it C for columns. And then you need to have this right here be, it could technically be 1 through 3, but it's 1 through the number of columns in X. It might not work anymore, because you can kind of put together the 2 videos now and see what to do. So this might fix it for everyone who's working on it right here, but you have to have the columns is what you're switching. So when you write your thing to check, when you look at your while loop, you're going to X, and you're going to the first row, first column, sorry. First column, there we go. I'll do that. And that should go to first column, first observation, and no, we want to go, sorry, I got this in the wrong spot. There we go. It's 1, 1, but then when this becomes 2, and then this will become 0. So while we have that this right here is not equal to 0, while it's not equal to 0, then we will continue to go I plus 1. So while it's not equal to 0, we'll continue to go I plus 1, and then we want to print what I is afterwards. So this will work here on the first column. Go away. There we go. And then this will work here on the second column. And this will work here on the third column. Oh, no. This will work here on the third column. So there it is right there. This is most of the question completed right here. And it's showing how you shouldn't have this as 3 right here. Just think this is the thing that I'm changing. If you kind of saw what I changed it through, I changed it from 1 to 3. And then think about the mechanics of what we have on the screen. Does that make sense right here with what we have? How we have that this goes 1 through 3. So does the I above, well, yeah, it needs to be in the while loop because it'll need to, no, this should not be in the while loop. This will need to be in the for loop because every time the for loop starts, it'll need to reset it. Because every time the for loop starts, it'll reset I to 1, then it'll run the while loop right here, and then it'll do that. So it'll do those things right there. So it'll do all that. Let's say. There go. It looks so horrible. Ah, what did I do? See, I did something wrong. Oh, haha. I'm not doing it. I'm not finishing it. I could finish it, but I'm not. I could finish this I could finish this code right here in, how fast do you think I could speedrun this code right now? How fast do you think I could speedrun this code? Since the answer was 6, I realized what it was, and I looked in the right spot, and I was like, oh, because I know how the data looks. I could finish this in 1/100th of a second. But I'm not gonna do it. So, you need a placeholder in there. You need something that changes what the columns it's going through. And so I didn't put the placeholder in my for loop, so the for loop is not changing what it is. I want people to think over these things. I want people to think over why it's not working. So it is moments away from working right now. How are we doing, Jake and Parker? Is it working? How's the code looking? Is the code running? Is it still broken? Is it working? Is the code working? For some reason, I'm only getting the output of just 6. So if you're getting the output of just 6, what column are you analyzing? My code is broken right now. I could fix it in a moment. If you're getting just the output of 6, look at the data frame and think about what column you're analyzing if you're getting just position 6 as a 0. If you're getting just position 6, I'm just getting 3s, then it's only putting the output of this one, so it's not changing past the first column. So if you're getting just 3, it's only analyzing the first column, and so you have to make it change between the columns. And this code right here is super close. My code right now just analyzes position 3. Can anyone explain in words for people what? Don't say exactly change that to that, but because I kind of did it for a moment if you saw it quickly. But can anyone explain in words why my code is not working? I'll try to explain in words next. Can you explain in words why my code above is not working? Can anyone debug this code? It'd be a decent test question to say change what to make this code work. What is, well, don't say change what to what. Someone might say it. Don't say it though. What is, there's just, we need to go through all the columns. And so if you look, this is what's going to change for the for loop. And so when the for loop runs, C goes, would you have to have C? No, so C will change for us. When the for loop runs, C will change through the values of it. So C will go through the values of 1 the first time, 2 the second time, and 3 the third time. So the for loop will change C for you. So C will change as the for loop runs. The for loop will actively change what C is. So does that make sense? Since the for loop will change C every time it runs. There's the big hint right there. The for loop will change C every time it runs. When the for loop runs, it'll start C off as 1, it'll run, and then it'll start C as 2 or do C as 2, then it'll run, and then it'll do C as 3, and then it'll run again. So think about that, since every time it runs, it changes what C is. Who has questions? I think, I'm hoping to hear Parker and Sean get it. I hope they see. You just have to make sure that you're changing what you're going through in the for loop. And you don't want this to be I because you've already assigned I to the while loop. Because it'll overwrite, probably, so you might have this right now, Sean. It does, awesome, Parker. Is it working now? It's working, I'm assuming you're saying. If you have this right here, what is going to happen? The for loop is going to assign 1 to I, and then you're going to overwrite 1 again, but that won't change. And so if I run this right here, and I put this right here, then, oof, it's going to be, that's going to be a mess. Yeah, that's what I thought. That's a mess. So I did, yeah. If you're on this, you'll get 333. If you're on this, you'll get 222 or 555. And you're on this, you'll get 666. So, with this right here, yeah, and then print out, yes, nice. That's what I want to see. I want to see people like, this is the fun of office hours is like, we got to get you right there. We got to be like, okay, do you see it? And so my code consistently is having errors right here. You should not have the same placeholder for the for loop as you do the while loop. And then you need to put that placeholder somewhere. You need to put that placeholder somewhere. So, yep. Is that making sense? You need to put that placeholder somewhere. Just saying. Just saying. Is that making sense to everybody right there? You need to put the placeholder somewhere. For all those paying attention. Did anyone catch that? Put the placeholder somewhere. Just put it in, you run it. Hopefully it does. We're getting to the office hours, so I figured I'd drop some big hints. Yes, so that, I want you to think it over. I don't want people to stress these. Hey, what's up, Jake? Good to see you here. I don't want people to stress too much. Not doing. Awesome. Mine stopped printing, actually. You might have to send it to me, Jake. You might have to send it to me. That's so weird. Checking something out real quick. I'm so confused at times. I thought, One show. What up, Andrew? How you doing, Andrew? Oh, I miss you too, Jake. Can we go over chapter 6, homework question 1 with the histograms? Yeah, let's do that real quick. We got enough time. Let's do that. Let's hop over there. Let's go to space real quick. Space. Oh, click wrong buttons. So let's go over chapter 6. I need to pull up the assignment. Do I not have Canvas open? 2 seconds right here. That one's a tricky one. And so... And let's hop over here. I'm getting the My Pearson open. My Pearson takes longer to get to. I have to click through 4 windows to get over to My Pearson. I'm about 3 windows away. It's like as quick as the website's gonna load, I can get there. And I'm almost there. Chapter 6 quiz preview replace questions. It is the first one, and I think it's here also. And did this do it? Yep, I think we found it. Let's hop over to the main screen. Okay. So here we are. We're over here on the main screen. Oh, good, Jake. That's glad to hear. Is this one you're talking about, Gigi? We're talking about this one right here. This one's a little bit confusing. This is a scatter plot. It's I think it's on the quiz and the homework. Is it this one right here? Is it this one? The quiz and the homework, I think, have the same thing. Awesome. So when you look at this one right here, here's where people get confused. Is a scatter plot is a what display of variables? A scatter plot is bivariate or univariate. A scatter plot is bivariate or univariate. I should have been here for the... A scatter plot is bivariate or univariate. It's bivariate. So we're looking at the batch number, and if you notice, as batch number increases, the number of broken pieces go down. But here's where people get confused. It's a little bit tricky. If you go right here, and you put this into Word, here's what I want you to realize, is that if we were to drop it this way right here, and then we were to reverse this, we have to reverse image it. You're like, who would have thought of this? I know, right? But I'm going to show the visualization of it and how it works. Okay, so I want you to see right here that the scale on the bottom now goes from 0 to 6. This is 0, this is 2, this is 4, this is 6. So I want you to tell me, with number of broken pieces right here that this says, how many batches had 0 broken pieces? How many batches had 0 broken pieces? Like if all of these were to fall down like ping pong balls, how many would they stack up right here? How many batches have 0 broken pieces? How many batches have 0 broken pieces? How many batches have 0 broken pieces? So you have to look up this way and you have to go, how many batches had 0? But don't worry about the numbers over here on this side. These numbers are just here to confuse you. Those numbers are the bivariate part of this. We will not look at those numbers. No, so wait, not that number there. Just, hey, what's up, Ahood? Good to see you here. How many of the batches had 0 broken pieces? Just looking up this way, just counting up 1. How many had 0 broken pieces? Just counting 3. You're right, Andrew. Great job. And we'll go right here, and we're going to make a mark here at 1, 2, 3. How many batches had 1 broken piece? 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 So you're just going to look at this univariate direction right here, just this univariate direction. How many batches had 1 broken piece? So we're just looking at this univariate direction for number of broken pieces. How many batches had 1? 7, yep, because we have 7 blue dots going up this way. So we'd actually go to right here. How many batches had 2 broken pieces? 1, 2, 3, 4, 5, 6. How many batches had 3? 1, 2, 3. And then 2 right here. 2, and then 1. Okay, so I'm going to make the histogram right here. There we go. I think that's got it. If that's 2, I think I need to put the other mark. Oh, no, no, no. Ah. Oh, it goes there, yeah. Okay, that's good. And then, oh, it's so close to perfect. Sure, we'll do it that way. The histogram's going to look like this. Let me move the thing over here. Move the bin. 0, 2, 4. But do you see the shape of it? It looks like stairs going down. That's going to be the key shape we need to see right here. So let's go back to the My Pearson assignment and look at the shape of it going down. And it looks like stairs. Ah, do you see the graphic that looks like ours that we just drew? Do any of these graphics look like this right here? Do any of our graphics look like this? Do you see a single graphic on the screen that looks kind of like this right here? Graphic C. Yep, and so it's really confusing, I think, especially at first. You have to think about this just reading it with this way. You look to the left to right. This one has 3. Just look at the broken pieces only left to right because you're only analyzing the number of broken pieces. So 0 should have 3 in the bin, and then this should have 7. So 3 7 is enough to identify that this is the one because this has 3 in the 0 bin and then 7 in this bin. So we actually took the time to draw out the histogram, and we got a very, very similar drawing to that right there. If you look, we get that stair step going down pattern just with the histogram. So we were able to draw it out and kind of identify. We had to twist and turn it to make it look a lot like ours. Describe the distribution as seen in the histogram. Very, very right skew, right to the high, left to the low, whatever way the tail goes. There's our monster dude. He's got rainbow eye today. Rainbow eye monster dude. We'll give him a tooth. He's a monster dude. He's a scary dude. Halloween coming up here. So we've got right to, did I get it right? No. What feature is more apparent in the histogram than the scatter plot? The skew of the distribution. We can see the shape of the distribution better right here. And then the scatter plot shows strength, direction, form, and unusual features. So the scatter plot's going to show a somewhat negative, linear relationship. And I think that should do it. We got it. Does that help out, Gigi, with that one there? Identifying the histogram is usually the hardest part of this one. Just understanding that we're taking this. Got it. Yes, that's great. Good work right there. Excellent work. You're welcome, Gigi. Anytime. Don't worry. Like, I never want people to think like, I'm like, oh, I did it in another video. Go watch that video. If you're here, we always try to do the questions to help out. So that's our goal. If you're here, we do as many questions as we can to help students. And I think that's got it. I think we're good to go. I'll be teaching here in just a little bit. My phone just rings like crazy. But I will talk to everybody later. Goodbye for now. Bye, everybody.
Dimensions has a somewhat looser feel to it.
Yeah, it's got an almost improvisational tone.